GVerse Predict 3D is a multi-attribute inversion solution by LMKR in collaboration with Lumina Geophysical. Predict 3D is fully integrated with geographics and relates well and seismic data to create rock property volumes for the entire survey area. In this video, I will create a V-shale cube using well logs and seismic data for the Big Moosehead dataset. I have my Big Moosehead interpretation open in SeisVision. I have about 9 wells, which you can see on the map view. The seismic data is about 270 inlines, 360 crosslines, and about 2 seconds of data. Let's open an arb line through some of the wells. I have the V-shale curves overlaid on the seismic to see how the curves and the seismic relate. V-shale is a computed curve, and these curves were created using equations in Prism, which is the petrophysical analysis tool in geographics. Once we have our desired log curves, we are ready to predict the property volume. The first step is to send the data over to the Predict 3D workspace. To do that, select the Send to GVerse Predict 3D option from the Tools menu. The dialog box that comes up gives you some information about the active survey. If you have multiple surveys in your SeisVision project, the active version of your active survey will be used in the predictions. The first thing we have to do is to specify a location for the Predict 3D workspace. You can browse to a location or type it in directly over here. Next, if you want, you can subset your seismic here by specifying inline and crossline ranges. For this example, we will use the full extents of our data. Then we have a list of wells that fall within the extents of our seismic. You can select the wells you want and send them over to the Predict 3D workspace. I'm going to just use the Select All option and select all the available wells. When you've made the selection of your wells, the Available Curve list box fills up with all available curves in your selected wells. Select the curves you want to use for your prediction. You can choose as many as you want, but for our example, I'm going to choose row B, GR, V-shale of course, because that's what I want to predict, and let's say DT. Once you have selected the logs, click OK to start the data transfer process. Predict 3D works with SegY data. Right now our seismic is being converted to SegY. We need all sorts of well information like headers, deviation and velocity surveys, formation information, and of course the last files for our selected well log curves. All of this data is transferred over to the Predict 3D workspace. We can also run Predict 3D in standalone mode. In standalone mode, all data must be manually provided using the seismic and well data managers available in the data menu. In integrated mode, all the required data are imported from the SeisVision interpretation. Before we can start the prediction process, we have to configure our well data in the well data manager available in the data menu. The first thing to do here is to set the primary log, which will be the log that we will use to create the predicted cube. For our example, that is the V-shale curve. We can do that individually for each well or set it for all wells at the same time from the toolbar. Next, we have to define the analysis window. We can manually type the values for each well or use the formation information to automatically set the window from the toolbar. The status icons at the end give us information about whether we can use a well in the prediction process or not. A green checkmark means all the required information is available for the well and it can be used in the prediction. A red cross means that some required information is missing and so the well cannot be used. In this case, the analysis window information is missing, so we will not be able to use this well in the prediction process. Check on the wells you want to include in your prediction. Click on Close to exit the Well Data Manager and return to the map view. The symbols for the wells are color-coded to tell us the status of each well. Filled green circles are wells that are included in the prediction. Empty green circles are wells that were left out, and the red circles are wells that cannot be included in the prediction because they are missing some required information. Predict 3D has several tools to help QC input data. In Well View, you can look at multiple wells and multiple well logs. To open Well View, click the Display in Well View button and select the wells you want to view. By default, the primary log set in the Well Data Manager is displayed. You can choose to include more curves from the tree control. You can also turn on formations to see where they fall on the wells. Zoom in to see the log curves more clearly. The shaded area is the analysis window also defined in the Well Data Manager. We can change the analysis window from within the well view as well. You can also look at your seismic data. If you have any picked horizons, import them into the workspace using the Horizons tab in the Seismic Data Manager. Click on Add Horizon and choose the horizon file. These horizons will now show up on your seismic view. Choose an inline, crossline, or time slice from map view to open in Seismic View. You can navigate through your seismic, and when you get close enough to wells, they are displayed on top of your seismic. Here we can view the well bore, log curves, analysis windows, formation tops, any associated synthetics, and the horizons all in one view. You can choose which logs, formations, or horizons to view from the Preferences window. We can also set the analysis window from within this view. We are now ready to start our predictions. The first thing we do is provide the spectral decomposition volumes. If you don't have these volumes already, you can generate these using the Generate New SD Volume button. But if you have previously generated volumes, you can set the location here. Configure the parameters for your prediction. You can now start your predictions using data from wells that were included in the analysis in the Well Data Manager. Click the Start Run button to start the prediction process. The prediction process takes a little time to complete, so in the interest of saving time, I'm going to fast forward to the end of the process. After the run is completed, we get a couple of windows that help us determine how good the coefficients calculated by the prediction engine are. The first window shows us a couple of graphs that show the training and out-of-sample error curves. The training error is computed as we add more seismic attributes to the analysis. The out-of-sample curve shows us the results of automatically hiding wells one by one and computing the error between the computed curve and the actual well log. The section on the right-hand side lists a summary of the run. We can see for the run that we just completed the best set of attributes and their coefficients as determined by the prediction engine, along with all the input information and parameters used to compute these results. The second window is a well view window that shows the predicted log superimposed on the actual V-shaped curve that we provided as an input for the prediction. You can view these to see how well your predicted and actual curves relate to each other. Predict 3D lets users have multiple prediction runs within the same workspace. Again, in the interest of time, I will switch to a workspace where I have multiple runs computed for this dataset. I can view the results for any of the previous runs by selecting the run and clicking the View Results button. Both the Well View and Run Summary windows for the selected run open, allowing me to look at the error plots, the selected inputs, and the attributes and coefficients used by the run. I can now easily compare all my runs to choose the one that gives me the best results. So let's say we liked run number 2 and we want to use the coefficients and attributes computed for run 2 to generate our V-shell cube. To do that, I will select run 2 from the dropdown, provide a location to save my output file, and click the Generate Volume button. The volume generation process will start. I can also choose to directly send my generated volume to SizeVision by selecting the Attach to SizeVision option. But we will attach our volume later after we have done some initial QC for our generated cube within Predict 3D. We can look at what our cube looks like in Seismic View. I'm going to draw an arc line through some wells. By default, this shows the input data. We can change the dataset version to our newly created V-shell cube and see what the cube looks like along this arc line. Change the color palette to something that makes more sense for our data. We can also change the log curves to color fill mode and make the palette for both the curves and the seismic the same so we can better compare our results. We can see that our generated cube and the well logs correlate nicely. We can now send this volume back to SizeVision, where it will be available for use in all of the geographics interpretation environment. From the Output Volume Manager, select the cube and click Attach to SizeVision. The volume is now available in SizeVision, where it is added as a dataset version. Once the cube is available in SizeVision, it can be used anywhere in geographics. For example, we could use the V-shell cube in Smart section to help with geosteering decisions. This brings the demonstration to an end. For more information, please visit our website lmkr.com/gverse. Thank you for watching.